Hello? Okay, good afternoon. I hope you're having a good time here at NDC Oslo and enjoying the conference so far. So I'm excited to be speaking to present the topic of React Server Components. And okay, React Server Components, why should you care about them? Obviously, React and JavaScript is ever relevant, and with React Server Components, we have an entirely new way to build React apps. So React Server Components will allow us to fade the boundary between the client and the server to create rich user interfaces with minimal client-side code while still maintaining interactivity and performance. So my goal today is to introduce, motivate, and provide resources about RSC. And before I start, let me introduce myself. My name is Aurora. I'm from Norway, and I work as a consultant at Meta here in Oslo. And I'm a full-stack developer, but I work mostly on web these days, and I'm actively building with React Server Components in my current consultancy project. And I bring to you my view as a developer joining the cutting-edge web world and how I'm working and learning with modern technology. So the talking points of today will be first rendering strategies, then we'll get to React Server Components, what they are, how they work, the benefits and the drawbacks. Then we'll go through the Next.js app router, onto best practices and patterns when using RSC and Next.js. And then afterwards, I'm going to show you a demo app that I've made with some examples. And then I'll give my thoughts on working with RSC in a real project and the future of React Server Components. So let's begin with rendering strategies. You can't really have a talk about web development without mentioning them. It's a crucial prerequisite. So I won't mention every type of rendering and the history of the web here, but I will pick and explain some relevant topics. And this stuff will probably be familiar to a lot of you. So static website rendering is the most basic rendering pattern where all web pages are assembled beforehand and uploaded as static files to a storage bucket. And it can be built with plain HTML and CSS or combined with JavaScript. And it's delivered exactly the way it's stored, meaning nothing will change unless the code is changed. And although quite simple and efficient, it doesn't handle dynamic data or interactive website well and is impractical to maintain. A use case for this could be an informational website for a business. And you could say that this is the old way of making websites and it's not used very much anymore. Multi-page applications, on the other hand, can handle dynamic data. So in MPAs, HTML and data is merged on the server per request and sent as one package to the client. So the user will open the browser and is served the merge result. And the entire page reloads and per request or navigation to a new page. And MPAs can be created, for example, with the ASP.NET MVC pattern or with PHP or Ruby on Rails. Use cases could typically be an e-commerce app, for example, Amazon as an MPA. So what are the pros of MPAs? Firstly, all page content can be read and indexed by search engines because it's rendered HTML, allowing them to appear in search results and be optimized for it. Then, there is no restriction on the number of pages you can add. Performance is going to be the same, meaning they have unlimited scalability. And last, they can provide more website insights. So for example, Google Analytics can create reports for each page. And the cons? They have a slower overall performance because they fetch each page as a package of HTML, CSS, and JavaScript from the server as it's being navigated to. And next, since every navigation causes a full page refresh, it can be hard to add real-time interactivity. And they can be harder to maintain because each page needs to be maintained separately. Then we have the single-page application, or SPA, also known as client-side rendering. A SPA will typically be a React app of Create React App or a Vue.js app, Angular app. This has been the most common way to build an application for many years. And in a SPA, the bundle.js file includes everything needed to build the app. The entire HTML is created on the client when the user opens the URL, and the page is blank until the JavaScript is downloaded, parsed, and executed, and then the framework, like React, will start building it inside the root div and finally load the data. And after it's loaded, only data in JSON format is needed to update the UI. The use cases for a single-page application can be any web app that needs to be highly interactive. So what are the pros of using a SPA? First, they're fast, there's no lag, they've got instant information present and smooth transitions after the initial load. And this is because everything is loaded initially and not re-requested per page as with an MPA. Second, they're easy to debug because everything can be logged in the browser because it's browser only, such as data, page element, and network operations. And third, since everything is downloaded initially, they can work offline afterwards, cache data, and then update when possible. But there are some significant cons. Most importantly, they have a slow initial load, which is increased with everything that is built on top, such as libraries, because it is all added to the JavaScript bundle. And meanwhile, the user is just looking at a blank screen and then afterwards a bunch of loading spinners. Next, search engines like Google cannot know what's on the page because the crawlers typically read strings like HTML, and your spa won't show up in the Google search results unless it's optimized in certain ways. They also need JavaScript to function, and therefore they cannot be progressively enhanced, and they also run poorly on devices with a lower processing power. And finally, they cannot hide information from the client because the data only exists there, meaning such as API, if you're going to have API keys, you need to store them somewhere else, like a backend or a serverless function. So the key difference between a SPA and an MPA: in a SPA, everything loads initially, and only data in JSON format is requested for making updates, whereas in an MPA, the entire page reloads per request. This brings us to SSR, which combines the advantages of an MPA and an SPA. So instead of generating the entire application on the client from the JavaScript bundle, server-side rendering means that you pre-render the initial pages on the server and then send them on demand. And this lets the user go to a URL and instantly see a fully formed page with components, and they can start reading the content immediately without waiting for React to build the page. And then the JavaScript required to interact with the page is sent alongside the HTML. And in relation to SSR, we also have something called static site generation, or SSG, which lets us pre-render pages in the build process of the app, and then upload them to a storage bucket. So the result of SSG is the same as with the quick and simple static website rendering, but now you can generate the pages from, for example, React code. A problem with SSG is that the build time scales linearly with the number of pages, meaning if you have a lot of pages, you could be waiting a long time for your app to build. And you have to rebuild and redeploy the site whenever the data changes. Server-side rendering is implemented in the so-called meta frameworks, which are frameworks around other JavaScript frameworks, such as Remix and Next for React, SvelteKit for Svelte, and Nuxt for Vue. And these frameworks are full-stack implementations of a web app, meaning they have their own server with things happening. They support both SSR and SSG and can decide when to use what. So for example, an app has a couple of pages, which of one of them it has data that is changing. In the build process, all the static pages are rendered, and then when the user opens the app, only the page that has dynamic data will be requested or rendered at request time. And these meta frameworks also typically include things such as file-based routing, APIs to handle data fetching on the server, caching capabilities, and image optimization features. So let's get back to that JavaScript that is sent along with the pre-rendered pages in SSR. We still need JavaScript to run on the client to handle any interactivity. So instead of conjuring all the DOM nodes from scratch, the framework, like React, will adopt the existing HTML. And this process is known as hydration. So the framework will attach the event handlers and, for example, fire effects and add state. And afterwards, the page is fully interactive. However, it essentially has to rebuild the entire tree and then compare it with the existing one to know what to hydrate. So this quote by React Core team member Dan Abramov explains it well. Hydration is like watering the dry HTML with the water of interactivity and event handlers. So there you have SSR in a nutshell. Done by modern frameworks like Next.js, it lets you load the initial page quickly, yet still have an interactive spa. Now this sounds great. However, SSR isn't perfect. First, after the initial fetch of the HTML, the browser will download the JS code, parse it, and then execute it. And this causes the pre-rendered HTML to look fully interactive, but in fact, it doesn't contain any JavaScript yet. So the user is stuck in a place often referenced as uncanny valley, where they will click a button, but nothing happens. And the time until they can interact with the page might even be longer than what it would have been for a plain spa version of the app. So why does this happen? First, you have to fetch everything before you can show anything. All the HTML with the data fetched must be processed on the server before it can be sent to the client. Second, you have to load everything before you can hydrate everything. That's because React needs to match the tree in the browser with the one from the server. Third, you have to hydrate everything before you can interact with anything. React will start the hydration and then won't stop until it's done. So there are many techniques being utilized in different frameworks to solve the hydration problem. Partial hydration can be used to define that only certain components need to have JS attached to them. For example, in Astro, you can define which components to hydrate with the directive client load. And you will also see this in React Server Components later. With progressive hydration, you can lazily load components JavaScript, for example, with Astro's client visible or with React suspense. Selective hydration will let you prioritize which component to make interactive first based on user interaction. And this is also possible to do with suspense. And there are a bunch of other techniques being implemented in other frameworks, such as with resumability in Quick. Let's also mention the concept of streaming. It's a part of the Fetch API of ES6, and it's available in React 18 and a big part of React Server Components performance. So streaming allows you to break down a request into smaller chunks and then progressively send those chunks from the server to the client and render each chunk as it's streamed in. And we can use it to send components down to the client as soon as they've been generated. So finally, with all that knowledge, we can move to React Server Components and how they solve the problems that we saw earlier. What if we could decide when we needed the behavior of an SPA or an MPA all in the same stack? And I'm going to be using some simplified examples of code from the demo app coming up later here in this section. So what are they? React Server Components are components that run exclusively on the server. Server components never re-render. They run once on the server to generate the UI. And their JavaScript is never sent to the client. And when I say rendered on the server, I mean the server that is part of the full stack framework, such as Next.js, or during the build process of the app, not some .NET REST API. So this is the frontend's own backend, which in many cases eliminate the need for writing a REST API. And server components differ from server-side rendering because they are never hydrated, meaning the resulting app is partially hydrated. Hydration to non-RSC components can then happen concurrently while RSCs are streaming in, since the compute load is shared between the client and the server. And since RSCs are run exclusively on the server, we can write database queries right inside our components. So here's an example of a simple server component called JokesList. I can query my database through an ORM like Prisma and have the data available and component fully rendered before it's sent to the client. Server components also introduce async components, which is basically an async function that can asynchronously fetch data on the server without causing any issues for the client side. And you can do any kind of data fetching in here, such as calling your API. Because React Server Components only render on the server, this means that a big chunk of React API is now incompatible with them. For example, we can't use state because state can change, but server components can't re-render. And we can't use effects because effects only run after the render on the client, and server components never make it to the client. We also can't use any browser-specific APIs, such as window.location, because it doesn't exist there on the server. And we can't use onClick or onChange because that requires client-side JavaScript. So server components themselves are simple, but the React server component world is more complex. We still want to have interactive components that include state and effect and event handlers. So because of this distinction, there are now two types of React components: server components and client components. And client components are the normal React components that you're used to, that you can do whatever you want to inside. Note that they are still pre-rendered on the server during the build and hydrated, such as with the pre-existing SSR. However, client components must be marked with use client. That allows us to use things like state and effects and onClick as normal. So here's an explanation from the Next.js app router docs on the limitations in server and client components. If you need to fetch data, access backend resources, keep sensitive information on the server, or keep large dependencies on the server, use a server component. If you need to add interactivity like onClick or onChange, or use state or effects, or use browser-only APIs, use a client component. So how do React server components work? What happens is that React renders server components into a special format called the RC payload. So this is a streamable format that represents the DOM, like a serialized version of a React tree. And the RC payload contains the rendered server components with holes of references to client components and the props they pass down to them. So it is used both in the build to generate the pre-rendered HTML. It's used both to generate the pre-rendered HTML on the server and then to update the DOM on the client without a need for JavaScript. So here's what it looks like in the console. We have the initial server-side rendered HTML of the page, as well as the RC payloads, which is identifiable by the _RC name, and multiple client-side JS bundles. So these are all used together to build the interactive page. And since this jokes list component is defined as server only, it doesn't need to be hydrated at all, and its JavaScript is never shipped to the client. And as with everything, it's quite complex when we start digging, so let's just leave it at that for now. When an RC needs to be re-rendered due to a data change, it refreshes on the server and seamlessly merges into the existing DOM without a hard refresh, updating only the parts that have changed. So as a result, the client state can be preserved even as parts of the view are updated from the server. And this is possible because the RC payload contains references to client components and can leave them untouched. What are the benefits of using React Server components? Firstly, data fetching. Data fetching can happen in components before they are sent to the client and will be faster since they can call the API or database in proximity to the resource. And inside RCs, you have access to all your backend resources. Next, they can ensure security by keeping sensitive data and logic like API keys on the server and never risk exposing them. Then, caching. By rendering on the server, the result can be cached and reused on subsequent requests and across users. And bundle size. Server components allow you to keep large dependencies on the server, meaning you can exclude all that JS for those components from the bundle without restricting your use of them. For example, a common library like Lodash, which overall will lead to a more performant application. Server components can furthermore be streamed, meaning they can be sent in chunks and viewed as they become ready. Therefore, they integrate naturally with React 18 suspense. And finally, developer experience. There's a lot less hassle on the client with effects and keeping data in the state. Just fetch it async off the client. RC, however, comes with some drawbacks. Firstly, they require a framework. In practice, you will only be using them in meta frameworks like Next.js due to their need for a certain bundler and router setup. You become bound to the framework's way of doing things. Second, they create and increase complexity. So as a web developer, you now need to understand a lot more concepts than before when you were just making a spot with Create React App, such as what you can and can't do on the server. Next, it can be hard to onboard new developers because the learning curve is a lot steeper when you're aiming to write quality apps. And finally, it's still relatively new and not everything has been figured out, such as testing and compatibility with other libraries. For example, many CSS in JS libraries like Emotion and Style Components do not work with RCs. So for that, you need to use alternatives like Linaria, Panda CSS, or Material UI's Pigment CSS. There have also been a lot of bugs since the app router was marked as stable, but it seems to finally be settling down now. So how can you get started with RCs? The most reasonable way right now is with the Next.js app router, available from version 13.4 onwards. So Next.js is made by Vercel and is battle-tested and enterprise-ready. React Server components are actually a part of React 19, but developed closely with Vercel and Next.js, which is good for building apps with them because everything is optimized and working smoothly, and the entire React ecosystem follows. To make a Next.js 14 app, run this npx create command and define whether you want TypeScript and Tailwind and such. And you will need the app router option set to yes to use RCs. That will generate the boilerplate for you, and you can start using them. So there's not a lot of files to confuse you here. It's mostly standard files such as package.json, tsconfig, and some config for Tailwind and ESLint. So what matters here is everything inside the app directory. In the app router, you will be coding server first, meaning everything you do is a server component unless specified otherwise. Which means here that the layout and the page file are server components by default. In the app router, you define routes by making folders containing a page.tsx. That makes it a valid route. And I have some routes here, /jokes, and then a /new and /jokeid subroute, which is a dynamic route because it is parameterized. And then you can use files with reserved names such as notfound.tsx, error.tsx, which are error boundaries that will render inside the layout of the route, as well as loading.tsx, which creates a suspense boundary around the page. And all of these can be granularized, so you can add them to the root or to subroutes or wherever you want. And there are also more features like ignoring folder from routes with underscore or grouping them with parentheses. You can also define API routes here, like in the pages router. And the route.ts file is a reserved name and will allow you to create API endpoints. Then there is support for SEO with, for example, meta tags. So they can be added to any page or layout and can also be generated dynamically, for example, using the route params. With Next.js comes a lot of optimization, such as caching. All pages generated in the build are cached on Vercel CDN if you host it there. And they will optimize your images if you use the image tag, and will do things like preload your pages when a user hovers a link. And it has built-in font optimization. So how do you use React Server Components in Next.js the right way? What are the best practices and development patterns to get the most out of them? The best practice is going to be to move your client code to the leaves of the component tree. In this way, you ensure you do not ship any unnecessary JavaScript to the client. And then React will hydrate only these client leaves, as we know as partial hydration. You could, in theory, just put use client on your root and then code however you want, but that means all your components will have their JS shipped and be hydrated, which just takes us back to standard server-side rendering. But don't be afraid of using client components. It's normal to have bigger client component sections because there are sections that are going to be very interactive. To use a client component in a server component, you simply import it. So here, the delete functionality has been extracted to a component with use client because it needs an on-click event handler. However, when going the other way around, you cannot do the same without turning the server component into a client component. Instead, you need to slot them as props, and they will fit as separate chunks into the client tree. So the client component here does not know what is being passed down, and this can be referred to as the donut pattern. So this means that our tree can look like anything we want, and we can add client-side logic in the parent components as well. So in this graph, only the green components are hydrated and contain JS, and the rest is just HTML. With this pattern, we can furthermore implement things like state management. By providing a wrapper client component with state, for example, using React Context, which only works on client side, we can use the state in the leaves without converting the server components in between. When combined, this allows us to make apps that are extremely performant due to their large amount of non-hydrated content, while still being fully interactive. You could have a donut pattern collapsible sidebar, theme toggle provider, search, and buttons on the client side. And then you can share your state between your components however you want. When building an RC component tree, there will be some limitations between the client and the server components. So for example, since the client component exists on the client and server component on the server, props need to be serializable. So that means that we cannot pass functions through the server boundary. Instead, we must create API endpoints to communicate between them when we can't use props, or React's 19's server actions, which I'm going to talk about also later. So how do we manage data with RC and the app router? I already showed you that you can make database queries through an ORM like Prisma, and you can of course also use the fetch API, and there are a bunch of parameters you can add here, such as cache duration, tags for revalidating the data, and more. And here's an example showing you what you could potentially do. For example, getting a cookie and making an authenticator request to an API. Yes. So if you use the same data in multiple components in a tree, you do not have to fetch it in the root and then pass it down. You can fetch it in each component where it's required because it's automatically deduped, or you can compare it like to memoization almost. And you can compare this pattern to React query, where you will call your hooks wherever they are needed, and they will all call the same cache data. Plus, you can pass down to a client component when you need it, for example, like the options of an autocomplete component. What about data mutation? So I mentioned that you can create API endpoints like in the Pages router, but let's skip that for now and look at something way better called server actions. So server actions just became stable with the release of Next.14, and they are the preferred way to mutate data. They kind of complete the whole React Server component story. It's simple. You mark a function or a file with useServer, and then Next.js will make a hidden API endpoint for you, allowing you to call it from anywhere, like from a client component, which solves the problem of passing functions between the server and the client. And in addition, it will give you type safety between the server and the client using RPC. So here I have a file marked with useServer, turning the function inside it into a server action. I can now call this from, for example, a client component. And that's all I need to do. However, I also need to tell Next.js that I have changed something inside the data in the React Server component, and it needs to purge the cache and revalidate the view and fetch new data from the database. So I'm going to call revalidate path with the route. Looking at our data management graph, the server action seamlessly takes us back from the client and to the server again. Server actions also integrate nicely with form submissions. So here I have a form and a function marked with useServer. And when submitting the form, the action with the action property, it can, without JavaScript, call the server action and add a joke to the database. And again, I have to tell Next.js to revalidate my view. And there's so many possibilities here, and it's extremely efficient to develop with. So here's an example of something I have made for my current consultancy project where we use RSC. In this example, there's a client component collapsible container, server component fetching data mapping to server component messages, then an interactive client component input field, submitting with server actions, and finally a client component wrapper around the messages to handle the automatic scrolling. So by weaving the server and the client together like this, everything that does not need to be client-side will be server only. So there you have it. React Server components in the app router allow you to do whatever you need to do, whether it's MPA functionality or interactive spa stuff, and include SSR or SEO or any kind of functionality you need, all in the same stack. So that's quite amazing. And hopefully you remember some of these terms by now. It's a lot. And React Server components definitely bring a new mental model and architecture. So let's get into a demo of this joke app. It's a remake of a tutorial app from the Remix docs, but of course it's very different because I'm going to be using RC and Tailwind and server actions. And it's also containing very simple implementations to not clog the code with complexity. So my setup here is the Next.js app router, uses Tailwind and Prisma as an ORM, and it's using also an Azure SQL database. So let's have a look at what it does. So there's a button here to get a random joke. There's a list with jokes. There we go. And there's a button to add your own joke. And I can say, for example, arrays. Why was the developer unhappy with their job? They wanted a raise. So let's add this one. So now it's added. And we can also delete this joke. So I'm just going to delete that. And that's pretty much it for this simple app. So let's head over to the code and look at that. So I'm just going to my local version here. And this is now the Next.js app router. You recognize this from the slides earlier. There's some validation stuff for my schemas, Prisma for database. I have a lib data access layer here with actions and services for fetching and mutating data, components and UI components. Then there's the app router and the jokes route here. So there's a layout for this, and this is now a server component because there's no use client here. And there's a header, footer, and this is all server-side. We don't need any client-side code for this. Then there is a sidebar, which contains a random joke button, which is this one. So this button is extracted into a component because it's a client component. And we're going to use the router API, which is client-side, to refresh the page. Then there is a nav button here, which is just a link that takes us to this page. And a jokes list component. So this is the one that I showed in my slides. It's an async component because it's asynchronously fetching data inside the component from the database. So we can do this now. And then mapping them to links. Then there is the new joke route here, which I'm currently on. Did I show this? Oh, yeah. And this is the form. So here I'm using the form component with an action property, which is, it's actually kind of the old way of doing things with like web standard stuff, but it's now been enhanced by React so that we can call a server action here. So this is server action. It has useServer. It receives a form data object from the form and can now add this to the database with only that code and then revalidate the path to regenerate the server component. So that when I add something here, it will add it and revalidate the view. And then there's an add button, because maybe you saw that it was like saying adding here. And the reason for that is because I'm using a client component and a React 19 hook called useFormStatus to say adding as the action is underway. And there's a lot of React 19 hooks that I don't have time to talk about today, but they work really well with React Server Components to give you feedback on the client side. Let's also look at the joke route, which is now this one. And inside here, I'm generating some dynamic metadata, and then asynchronously getting a joke here based on the route params, which is the one I'm on here, excuse me, here, based on the ID, and then displaying it and also showing a delete joke button. So this is now also a client component. The reason for that is because I want to use the onClick property, which is available only on the client side, to delete a joke. And I'm using a transition here, which is a React 18 feature, now possible to use with async functions in React 19, to delete a joke and get the pending state of this action, so that I can see that it's deleting. I think that's it, but I also have made some demo routes here so that I can talk some more about the concepts I've been explaining. And maybe you encounter some of these problems and you can use this in the future. So first, I've talked about that you can nest server components in client components. So here I have a server component, a client component, and server component again. And this is now interactive. And this is possible because I'm nesting it as a children property. So a client component is receiving children, doesn't have to know what it is. It's just doing its stateful thing and then rendering whatever it's received. So if I look inside the console, the client is printed on the client, and the server is printed on the server here. There you go, server. Yeah. Then I also mentioned revalidation. So I can add client state here and revalidate my server component without losing my client state. And that's possible because of the server components having references to client components. Then making state, so making, for example, a global state with React context. So I have a theme context here, which is now wrapping server content. Then there's a server component here, a set theme component, which is a client component, which is using this theme provider to set some state. Then a use theme component, which is using the state, also on the client side. And still, these server components in between are not being converted into client-side code. There's a lot you can do with forms now. So you can, for example, validate on the server. So let's just see what it looks like. So I'm doing binding to an action, which is doing some server-side validation and logging an error if I'm not making content that's long enough. So it's going to now say server error. Then I can also do validation on the client side. So I'm doing the same here, just validating on this client side, ensuring a certain number of characters. And it will now give me an error on the client side. And when I combine this, I can, for example, make a React hook form, if I want to do that, which will have the standard client-side validated React hook form functionality. But I'm also going to validate on the server for security reasons. And I'm actually requiring one more character there, so this is going to fail. And now it's optimistically updating this and then failing because the server didn't actually approve this. Add another one, and now it's added. And this is now using another React 19 hook, which is really useful for making optimistic updates, so check that out. Finally, more React 19 stuff. I'm using a new hook, useActionState, to allow me to get response from the server without JavaScript. So now my server is returning the validation, and I can display it on to the user here. And when it works, all is well. And this now works without JavaScript because of this action property combined with the useActionState. Next up, we're going to be streaming server components. So you're doing something on the server, you have to display something while it's happening. And you can use suspense for this. So if you saw that, hold on, I'm going to show it again. I have some different components with timeouts that are now resolving. I'm going to show you what it looks like. So this suspense page is now slow. The jokes header is slow, and the slow function just awaits a promise, by the way. Jokes header is slow, and this jokes component has a slow function. So this could be happening, and the way we solve that is by using this suspense to kind of piece it into parts and display fallbacks for each of the slow things happening. So now I have a loading to handle this first loading here. Then I have another suspense explicitly here, and then finally one for the jokes. And while this is happening, I can still click this button, even though the server is giving me, we're waiting for the server here. And I'm not going to show the React query, but it's good to know that if you want to use client-side fetching, you can, but typically you won't need to unless you really want to, or you're going to be polling data. So this is now refetching. Where is this? Refetching at an interval. So that's useful with React query. Refetch. Yeah. And as a final one here, you can also use server actions to, for example, respond to some onBlur, onChange event. So here I'm calling a server action onBlur to save a joke, like that. I think that's it for the demo. So I'm going to jump back to my slides here. Let's see if all is well here. There we go. So this is the Lighthouse score of my joke app. And I didn't really try very hard to optimize this. I just followed the patterns I've been mentioning. And of course, this is a very small app, but it still proves the point. And all in all, you can build very performant apps by default, and the limitations of RC will make your code better, unlike in plain React, where you can just do whatever you want. And here's also a badge for the app when sharing a link to a joke. As you can see, the dynamic meta tags creates a badge. So next, I have real-world experience with RC because I'm building a medium-scale production app with it. So let me mention my requirements and my experience. I'm working on a project set to last at least 1 year, and it's a rewrite of an existing MVC app that has a lot of technical debt. So I was lucky enough to be given the responsibility of picking the technology for the front end of this new solution. And the app would contain interactive dashboards, complex forms, articles through a CMS, and a lot of static data, and a need for SEO. It also needs to be mobile-friendly and accessible and support multiple languages. So a big part of the app, and something I made sure to proof of concept with RC before I chose Next.js as my framework, was the customer's design system component library. And this app is a great case for RC because it can server render a lot of content, but still be highly interactive when it needs to be. And I'm finding it to work very well so far. However, I have had to do quite a lot of trial and error and research to build functionality that is non-standard. For example, I had to create wrapper components for the customer-specific component library components to use them in my project and put server components inside them. I've also had to pick my internationalization library without much guidance from Next.js. And it's working very well now, but there were complexities in the beginning. And finally, testing RC is not covered properly anywhere. And to test async components with React Testing Library, there's currently a need for a workaround. But all in all, it's going really well. The app is performant, fulfills requirements, it's maintainable, enforces best practices, and the developer experience is great. So the Next.js app router with RCs inside provides so many tools to let me focus on building my app. To finish this off, what is going to be the future of RC? There's no doubt that this is the way React is going now. It's not just some hype cycle that will die out. It's the result of many years of work from the React team. For example, Vercel is actually in the progress of migrating their own dashboard to the app router. So in this tweet, the CEO of Vercel talks about the significant performance benefits they are seeing. Multiple other frameworks are also implementing RC, such as just recently Remix with the announcement of React Router v7, the framework Redwood.js, and most recently Expo for mobile development. So overall, big things are happening here. And there are so many solutions being proposed to improve the performance of web apps with the goal of finding the optimal balance between UX and DX. And this is React's take. Nonetheless, there are still a lot of things to be figured out as React server components are battle tested. So here's the repo for the Joke app. Everything is there, as well as the reference demo pages. And here's also some more resources that I used during my RC learning experience. So the React docs are very good, focusing more on the details of server actions, server components, and the new hooks. The Next.js docs also, they contain a lot of things, and you need to know about caching there. It's gonna be in those docs. And they have a bunch of template apps, and they also have a newly released free course called Learn Next.js, where you will build a dashboard app from scratch and deploy to Vercel. For YouTube, Bytecrad does a lot of thorough RC content, and Code with Antonio builds some incredible clones of apps like Twitch and Miro with full code-alongs on YouTube. He recently made the corresponding code paid, unfortunately, but the videos are still good for learning about the patterns that he's using in these clones. So I recommend these channels. And in addition, I do have real-world experience, as mentioned, so I felt the struggles and the wins. I don't have time to talk about it more, but you can chat with me later about that if you have something that you're experiencing. So thank you for listening. I hope you're as excited as I am and ready to try this. This is my social media links, and you can contact me on Twitter. And I have a blog with multiple posts about RC and the new React 19 hooks, like for building a reusable submit button, testing, integrating with server actions with React hook form, and more. So thank you. Do you have any questions? OK, I'm turned off now. OK, questions. If I'm going to be able to see anything here. I guess we can do it. Just come down if you have a question, I guess. Thank you.